In an inverse proportion, it works a little differently than a direct proportion. Inverse proportions happen when we have a more means less situation or a less means more situation. For example, it takes 175 minutes to drive home at 80 kilometers per hour. At 100 kilometers per hour, how long will it take? We're going to have more speed if we increase from 80 to 100 kilometers per hour. If we have more speed, will it take more time to get there? No. This is not a more means more situation. This is a more means less situation. More speed means less time to get there. The rules are a little different for building an inverse proportion than they are for a direct proportion, but we start off the same way. We find the two numbers with the same unit and we put them together. I see 80 kilometers per hour, 100 kilometers per hour have the same unit, so I'm going to put them together with this smaller number on top, on the left side of my equal sign. Then I look for the remaining number, and I see 175 minutes. The 175 minutes goes with the 80 kilometers per hour in this situation. But because this is a more means less situation, and it is not a direct proportion, it is an inverse proportion, instead of keeping the 175 and the 80 together in my equation, I deliberately break that rule and I keep them apart. Instead of putting the 175 on top so that it can be together with the 80, I put it on the bottom. And I put the x in the last remaining place. If I cross multiply, I'm going to get an answer that makes sense. Now, using the fundamental rule of proportions, I do top times bottom equals bottom times top. I get 80 times 175 equals 100x. 80 times 175 is equal to 14,000. So I have 14,000 equals 100x. I divide both sides of the equation by 100. These cancel. My x is now isolated. And 14,000 divided by 100 is 140. Now all I have to do is apply the unit of measure. What I was looking for was the time, and it's in minutes, so it will take 140 minutes to drive home if I'm driving at 100 kilometers per hour. An inverse proportion works the same way as a direct proportion, except for this one step where the third number that we place into the proportion is deliberately not kept together with the number it seems to go with in the situation, and are put in the other spot instead. This will work and will always give you an answer that makes sense. In this second example, 6 people cleaned the yard in 3 hours. How long would it take 4 people? We want to check this and see if it is a more means more, less means less situation, or is it a more means less means more? You have less people. We've gone from 6 people down to 4. Will it take less time to clean the yard? That wouldn't make sense. Less people cleaning the yard will take more time. This is a less means more situation. So therefore we're going to use the rules for inverse proportions to build the equation. The two numbers with the same unit are the 6 people and the 4 people. So I'm putting them together on the left, smaller one on top, as is my habit. Then, the 3 hours goes with the 6 people. So if it was a direct proportion, the 3 and the 6 would go together on the bottom. But because this is less means more, it's an inverse proportion. So I deliberately do not put the 3 and the 6 together. The 3 ends up on the top here. And the x goes in the last remaining spot. Cross multiplying, I get 4x equals 6 times 3. 4x equals 18. Dividing both sides by 4, the 4's cancel on the left, the x is isolated, and is equal to 18 divided by 4, which is 4.5, and the unit of measure is hours. This answer makes sense because this is an inverse proportion, and we know that because the situation is a less means more situation. When you work with proportions, always check the situation first to see if it is a direct proportion or an inverse proportion, and then follow these simple rules and you will get an answer that makes sense.